Our today talks is about gels in polymers and biomedical cause and prevention. It is the post number 36 and our homepage. Gels can occur either on the surface or bulk of the materials, and there are visual effects that will be carried out into your in your final products. Either it's like a balloon or other products that you have. There are four different categories for gels. One is cross-linked or degraded polymers. So polymers during extrusion can be cross-linked or can be degraded, and you can use FDIR to identify these. We will going to discuss each of these individually in future slide, and we will address how you can prevent that. The second category is contaminate, either like dust or dirt or foreign particles that come in your system. Again, you can use FDIR or SEM EDS mode to identify that. When you're running SEM, you have to make sure that in EDS mode you use a point mode for your mapping system to be able to identify if the dust or like a metal part. The third category is non-uniform crystallization. It's very important. This is very important for segmented polymers like polyurethane, PBAC. These materials, they tend to crystallize during extrusion, and that's a very aspect that has to be considered when you are extruding this material. You can use FDIR to identify if the source of gel is non-uniform crystallization. The fourth category is incomplete polymerization or high molecular fraction. This is coming from the raw resin, right? That's something that you cannot do anything about it because it's a resin related. And again, you can use FDIR and SEM EDS mode to identify that cause. There is a STM for detecting gels and counting them. The ASTM D3351. Basically, it's just forming a thin film and then observing that thin film with a microscope and measuring the gels in diameter and reporting them. But in biomedical industry, every company has developed their own method, microscope that they use, and also the gel size, that what would be considered as the critical size, that above that it could reject the part. But theoretically, and what we have observed in the industry, anything above 0.15 millimeter diameter gel could be problematic for downstream, right? And the reason for that is that it could create like a stress concentration point that later on would contribute to failure of the sample. And if, for example, the gel is a contaminate or is like a foreign particles, it could also create, it could impact the shelf life of the material, or it would create contamination for final part. As I mentioned, to prevent the gels, it's very important to find out what is causing the gel to form. So if the cause is cross-linking or degradation, then the very important thing is to check your temperature profile. Make sure that you are using the right temperature profile for the extrusion of the material. Your thermocouples are good in terms of detecting the right temperature. Make sure there is no hot spot in your system. Check all the points that you have inside your extruder, and you can create like a checklist. I know that sometimes it could be a little bit time consuming, but if you do this properly at the beginning, it will be much easier down the road, and it's to have a smooth extrusion. Also check the moisture level for your resin. Some resin, for example polyurethane, can react with the moisture, like the isocyanate group of polyurethane. When react with moisture, they create cross-linking fractions that would create problems for the material, and it would appear in form of gels in the material. Contaminants, dust and dirt is very important to make sure that from T0 when you pick up your resin from the dryer, or even from the the bag that you put in it, your dryer, all the way to your collection system, it's free of dust. There is no contamination from the surfaces. Make sure everything is clean. Again, your detection system like FDR, SMD, EDS would tell you that if you have a contamination from dust or metal, so you can track it back to see where is the cause. The third part is non-uniform crystallization. That is a very common way. There's a common way of to form the gels in segmented polymers like polyurethane or P-bags. For example, a polyurethane material, we call these segmented polymers because they have hard and soft segments, and that's how they control the diameter or hardness of the materials, right? They add more hard segments basically to increase the hardness of the material. And these materials, when you're extruding them, they have a potential to crystallize. And when they crystallize, they create like a gel point, and you can see them when you put it in front of the light. But when you put it under microscope, basically what you see in this, like these pictures that I've shown here, is like a dent. So it would diffract the light in a way that you see, oh, that's a gel point, but basically that's a dent, and it would tell you that, okay, there is a stagnant area in your extruder or in your helicoid or in your pin and die that specific point has a lower velocity, and as a result of that, the material would crystallize and create like a dent in that location. So to prevent that, ensure that you are using extrusion grade material. It's very important that make sure that it's very important to know that the material that you are using is designed for extrusion. Some of these polymers, they are originally designed for the general purpose material or injection molding. For example, a Palatine 90A is good for injection but not for extrusion. So using Palatine, make sure that you are using AE that is designed for extrusion. And that's address that issue, that post-crystallization during extrusion of the material. Clean the extrusion line properly. When you are setting up for your machine, when you are building the machine, in the morning, make sure that you clean the machine properly. There is no dent, there is no effects on the surface of the helicoids or a pin or your die. These all could create stagnant area when you are extruding and you create gels. I know that sometimes it be a little bit time consuming, but it's very important to do this, based off a checklist. Even you can put like a little camera inside of your barrel to make sure your barrel is smooth. The screw that you are using is designed specifically for that material. Is a polyurethane screw or is a P-back screw, in terms of, conventional screws versus barrier screws. And ensure that the temperature profile that you are setting is right for that material. That's a very, very critical one, especially for segmented polymers, right? For example, for P-backs or polyurethane, we want more shear rate to heat the material and melt it than the heating elements, right? Like the electrical elements that we have in the system. So more shear rate melting than electrical element, and that basically would create a more uniform and homogeneous melt around your circumferential when you're extruding. Ensure that you are using correct filtration system. That's also very important aspects of the extrusion. In extrusion, we like to use a screen pack. It's just to filter particulates and the other residual that is in the melt. If you are using a very tight screen pack, it could create a back pressure that would cause backflow into your system, increasing residence time of the material inside the extruder, and it potentially would create a degradation or a cross-linking that would impact your process of that material. You can see it like in the pressure that is not stable, it becomes unstable, and the gel that would appear on your material. One of the important elements in extrusion of tubes in biomedical is helicoid, and the helicoid has a very critical role in formation of gels, especially for the gels that are formed as a result of post-crystallization in materials like polyurethane or PBACs. So if you are extruding, a polyethylene or a PBAC, it's very important um, to make sure that you are using the right helicoid, that is the right design for that specific extrusion. And to do that, it's you can use ANSYS basically software to model the flow that is coming out of the grooves and basically going to your pin and die. That flow basically has to be all uniformly distributed around your circumference of your annulus. And basically, uh, you can use uh, Polyflow, that is a module within the ANSYS flow and package to model the flow coming out of the die. And it would tell you if you have an area that the flow is lower than the other point. Basically, that point would tell you that, okay, this design that you have for helicoid is not a good design. It would not uniformly give you a flow rate or a velocity and the shear rate. So you can get different contours from your modeling. You can get the contour from the shear rate. You can get the contour of the velocity um, at any planar angle, and then basically it would tell you that, okay, in that plane, how is the shear rate is distributed, or how the velocity is distributed. And basically, if the design that you have in terms of your diameter, your angles, the number of the grooves, it is a good design or not. The last item is incomplete polymerization or high molecular fraction in raw resin. Most of the resin manufacturer, for example, Lubrisols, they provide you with a gel count um, of their material in their certification for the resin. It's very important to check on that one. So this is like basically the first indication of how much gels is in that resin. The other method to do that is to dissolve the material in a solvent, for example, either THF or DMF material. And so THF is very volatile. You can use DMF if you do not have a proper ventilation system, and then use casting method to cast the solution on a glass plate and see if you have gelsy material. Again, you can use FDIR or STM element analysis to see what is that specific gel point, and it would the FDIR or STM would be able to tell you that, okay, this is a high molecular fraction, or it is an incomplete polymerization, that is, the chemical composition is different from the rest of your polymers, and basically it will not melt with the heating profile or the shear rate profile that you have. And then you have to use other methods either to filtrate or reject that lot.